Hi, everyone. This is Rob Gray from ASU and the Perception Action Podcast to get back in with another article review. In this one, I want to look at the issue of choosing task difficulty in training or practice. Right, this is an issue that we can cover from multiple different angles. In episode 105, I talked about one of the most well known approaches to this, the challenge point hypothesis, where we talk about functional versus nominal task difficulty. The article I want to focus on today, though, is the one listed there from a recently published article in Psychology of Sport and Exercise, looking at how well athletes themselves can understand task difficulty, right? And how well they can set the task difficulty, both in terms of being able to perform at that level and in terms of learning. And we're going to look at factors like age and expertise. So this was a paper by Schaefer et al. That just came out in this journal. So, as the authors point out in their introduction, right, being able to, as an athlete, to assess your abilities obviously is important for multiple different reasons, right? It's choice in terms of competition. It's important for choice of strategy, right? My pacing in a running race, whether I try to make a pass or a throw that maybe or maybe I'm not capable of, right? So we need to be able to recognize our abilities. And in the paper, the authors give a very kind of cognitive information processing view of this and metacognition and all these kind of angles. Of course, I would look at the same thing in terms of calibrating your affordance perception, right? You need to affordances, opportunities for actions in the environment need to be calibrated relative to our abilities, both our body scaling, right? How long our legs are, or how big our stride length, and also action scaling. For example, the work of people like Matt Dix that have shown that our perception of affordances in goalkeepers is related to how quickly they can dive to the corner, right? So it is critical that we be able to calibrate ourselves to environment in terms of our capabilities to know what affordances we can choose to act on depends on our abilities to act on, how fast we are, how quick we are, and so on. So the authors wanted to use in this study look at how well people could judge this for themselves, right? How well people can assess their capabilities, and they used this kind of paradigm from Rediger et al. From 2006. They called the selection margins paradigm, right? The idea is where the athlete chooses the maximum ability they have, what they can achieve, their maximum manageable task difficulty, it's called. So I can say, if I said, I could run a mile in 8 minutes, right? Something like that, right? You set that go. And then you actually have them perform, right? And you look at the difference between what they actually achieved and what they said they would achieve, right? And this difference is called the selection margin, right? And you could either be very conservative, so I could say I'm going to run 8 minute mile and run a 7 minute mile, or be overly optimistic and say I'm going to run 8 minute mile and I'll run a 9, right? So what they're going to use is kind of this metric, the selection margin, to try to understand people's ability to assess task difficulty. And I'm going to look at this from the data and the study, and we'll get back to how this relates to setting practice and designing practice and training at the end. So they did 3 different experiments in their study with 3 different motor tasks, right? So they had a skipping task, rope skipping, dribbling a soccer ball around a set of cones, and tracing something on a paper with a pen, right? And they looked at the main kind of independent variable they looked at in their study were the effects of age and experience, which in the first 2 experiments are confounded. And by that, I mean the older people were also the most experienced people. So you can't break those 2 apart. The reason they did the tracing one in experiment 3 is that something we don't really have any experience of, or we would assume it's relatively equal, right? Something we're not specifically practiced. Okay. So they have the people doing these things. They're asked them to predict their amount of performance. So how many jumps can you do in a certain amount of time? How long will it take you to dribble the ball around the course? And then they calculate selection margins. One critical thing about the way they designed the study was they designed it so that participants were really penalized for overreaching, right? For being confident about their ability. And I'll show you how they did that in a second. All right, so that's the basic overall design for all 3 studies. For the rope skipping, they took 26 females. Okay, they were active member of a rope skipping section, and 10 of them were beginners, and 16 were actually on a performance team. Okay, and for each trial, they were asked to estimate how many jumps they could make in a 10-second interval. They were asked to make this prediction about what they would do on the upcoming trial. Now, here's the bit about penalizing overconfidence. So what they would do was they were awarded points only if they got above the threshold they predicted, right? So imagine I said I can do 18 jumps, right? If I get 22 jumps, I get 22 points, right? So I'm getting rewarded for going over. I get the extra. But if I say I'm going to go get 18 and I only get 17, I get 0, right? So I get massively penalized for predicting more than I can do. So there's a kind of incentive to be kind of conservative in your these estimates. So that's the basic design. Then they went and measured and saw what people can do. The two main things they're going to look at in each of them are the selection margin. So how close were you to what you actually achieved, right? So if you said, people on average said they could do 18, did they get to 18? And then they're going to look at the number of trials where people got 0. So the number of times, so they did this multiple times, right? So number of times you actually didn't hit your goal, right? So those are the two main things to look at. And here's what they found. So in the rope skipping, what they found was that the beginners tended to be overconfident in their selection margin, right? The number of jumps they could predict was slightly larger than the number they actually achieved by less than one jump, while the advanced uh, jumpers were conservative. They were less than the can, but again, by a very small margin. And the difference between the two was not actually significant statistically, so we can't make too much out of it. What they make more about in across the whole study, and in this one in particular, are the number of times they got 0 points, right? So what they found was the beginners got significantly more 0-point trials than the advanced, right? And they actually found a correlation between age and the number of times you got 0, right? So the younger people had way more. So for example, I'm looking at the graph. If you're watching the video, you can see people under 10, they had 10 or so trials, one close to 15, whereas people in their 30s had less than 5 trials, right? So seemingly people with more experience and more older seem to be better at understanding their abilities in terms of doing this kind of measure. Okay. So, and in terms of the averages, the beginners had 8 trials on average with 0 score, where the advanced only had 4.5, right? So big difference there. The next one they did was soccer dribbling. Okay, they said 26 members of a soccer club, 10 advanced, 10 beginners, 16 advanced, right? They're asked to dribble a soccer ball around a course that was 20 meters long with 10 poles or cones, right? And the experimenter recorded their time with a stopwatch. The scoring was kind of the same. So you had to meet a certain level of proficiency, right? So if you got 20 points if you're over 5 seconds, okay, and 0 if it took you more than 25 seconds. And then along the way, there were steps of scores based on your prediction, right? Again, if you predicted you would do it the whole course in 15 seconds and you did it in 10, you would get a bunch of extra points. If you predicted you would do the course in 15 seconds and you did it in 16, you would get 0, right? So again, really penalizing the predictions, okay, over predicting. What did they find on this one? Essentially exactly the same results, right? The actual selection margin for the beginners was 0 exactly, which means they were exactly perfectly calibrated, whereas the advanced players was negative 0.5, which means they were kind of more conservative by almost half a second. The trials again with the number of trials was 0, where they didn't reach their prediction, was 10 for beginners on average and 6 for advanced. So again, suggesting, and then there was this correlation again with age, right? So, younger, less experienced athletes had more trials with 0. Okay. So that again, same basic pattern, right? The last one the study they did was, again, as I mentioned, was tracing. So basically you had a piece of paper where you had to trace out a curved pattern. You had to follow along a line. Around the line were these little 2 barriers. If you crossed over it, you got penalized, right? The reason they chose this task is the people in their study, at least, and most of us, don't have any specific training experience with this kind of thing, right? Maybe certain people do in their job. If you're an architect or something like Olfat, you might, but people don't really have a specific training. So we can separate age from experience. So they took 52 people that were aged between 9 and 27 years. They did this curved path training, and they had to do the same thing: predict how long it would take you to finish drawing out this path, penalized if you took slower, and so on. So the exact same design. What did they find? Right, they found there was a correlation between, again, the 0 point trials and age, okay, and the selection score. People were more conservative the older they were. They had less 0 point trials. So they seem to be able to separate out the effects of experience here, right? It's an age effect, right? It's because people were untrained, or all untrained. If you go, excuse me, if you go look at the paper, or you're watching the video right now with me, the correlations, you look at the graphs, they're a little bit worrisome in terms of numbers, right? So drawing correlations with the number of participants they have is a little bit dodgy. They are statistically significant, but it's the power there is kind of lacking. So it's a little bit, people can, you look at the graph, it's not really an impressive, strong relationship, and especially in terms of the tracing 0 points, the one on the right, if you're watching the video, it doesn't really look very like there's a strong relationship there to me. So it's a little bit questionable, but across 3 studies, they do seem to have these effects. So there maybe there's something there. So the authors conclude overall that beginners and younger athletes are less able to predict their ability, their task ability, how difficult the task should be. Um, More experienced are more, not surprisingly, better at it. Okay. One of the things they recognize, and one of the things that jumped out to me, I think, when I was reading this paper, is that the issue of variability, right? Younger, less experienced athletes are going to be more variable in their performance. So we'd expect them to have more of those 0 trials, just from variability, not from necessarily from prediction, right? So you're going to have some really bad performances and really good ones. You're not going to be as consistent in your outcomes when you're first starting, right? So maybe this 0 effect was more to do with variability than it is with terms of how well calibrated your performance are. But those are the basic predictions. So this was interesting for me. As I said, I thought, it was an interesting study. It has a little challenge, some of the things with sample size, and then the representativeness of the task. Maybe you could challenge. This immediately brought to mind a really important study. Can't remember if I've talked about this on the podcast before, by Simon Bjork in 2001. What they did in this study was they recreated the classic blocked versus random practice paradigm, right? So they had people learning sequences of keys on a keyboard. In the block practice, right, you learn just one key sequence, then you move to the next, then you move to the next. In the random one, you had to interleave key sequences. So you're getting contextual interference in the classic fact. And what they found in terms of performance was the classic blocked versus random result, right? People that performed the random practice did worse during acquisition. They made more errors, but they eventually caught up to the block group by the end of training. But there was a massive difference in retention when they switched to a new key sequence, right? And transfer. The random people had massively lower errors. And if you're watching the video, these are errors, so lower is better. They had way better performance than the blocked group, right? So in the long run, and when you look at learning, not just performance during training, blocked random practice is better. Classic finding. But what the new twist on this study was, they had people judge what they thought they could do, right? How well they're learning the task, how well they would do during the next trial. And what they found was that the blocked people consistently predicted they would be better than the random group. And importantly, they predicted that in both in the retention and transfer tests, right? So, and if you're looking at this graph, the triangles are always lower than the squares. They're predicting the lower errors. So the bottom line they made about this, and I think it's a good point, is people are not good at assessing what's good for their own motor learning, right? Performers are good at assessing how well they're performing now, right? They're not realizing that the random practice is actually helping them in the long run, right? So that's where, as a coach, right, you have to step in. Right. So overall, I think these kind of studies where people are predicting how well they're learning or their task difficulty, I think they're interesting for me. In terms of my interest in terms of the ecological approach, I don't find them too. I would go a different direction. I guess I would say, in terms of assessing calibration, where you're actually having people make affordance assessments, kind of like, as I mentioned, the Matt Dick study on soccer goalkeeping, where you try to match affordance perception to actual abilities by measuring those abilities or how well calibrated they are. So measuring knowledge of, right, the actual performance, expressing how well calibrated you are by your performance instead of knowledge about, which is a verbal explicit judgment, which I don't really think is that important. For we want to see how well calibrated you are in the moment, making the decisions, actually executing what you say you're going to do. To me, is less important. In these studies, performers aren't really attempting to realize their performances, so I don't expect a verbal passive judgment to be that well calibrated anyway. So for me, understanding how athletes understand their own abilities, I would go a totally different direction. The classic studies of Bill Warren and all the stair climbing and things like that. How well calibrated are your judgments of affordances to your actual abilities that you can, and your body size and so on, rather than how well can you predict explicitly. As I said, I don't find that particularly, I don't think that particularly important. Obviously, task difficult. This shows why you need a coach to set the difficulty. It also shows why, in adaptive methods, which I talked about, a few months ago, it's better to have some algorithmic or coach adjusting it rather than the player adjusting the level of difficulty. People aren't good at assessing the ability they need for effective motor learning. That's kind of the bottom line. And the top point I put there, this kind of brings into question to me how, this for me, it brings into question the importance of the research showing kind of the importance of self-efficacy and expectancy on motor learning. Again, just tampering a bit, not saying those things are important, but if your expectancy of how well you can do is not very calibrated anyway, why does it really matter as much as we think? I think that's an important thing to consider. So overall, I think this again is an interesting topic that there's lots more work we can be done, especially on the calibration of affordances. Okay, that's it for today's episode. If you're interested in helping support the podcast, I encourage you to go to patreon.com/perception action. Thanks and cheers for now.